Everyone. So in this YouTube video, we will be discussing about what is Tekton, how we can install it in a Kubernetes cluster, the use cases of it, basic architecture, and why we should prefer it over any other CI/CD tool out in the market. So I have covered everything in this particular blog post of mine about whatever we will be discussing today, and definitely the blog post link will be there in the video description. So Tekton is just a Kubernetes network framework for building CI/CD systems, and everything in Tekton is just a Kubernetes custom resource, which means the core components of Tekton like tasks, pipelines, pipeline runs, which are the core components of Tekton for building a CI/CD, are just a YAML files that we can apply to a cluster, and Kubernetes runs all of these as a pod under the hood. So I have provided the GitHub repo link here of mine, and in this particular GitHub repo, I have provided lots of YAML files for the installation, for building CI/CD from scratch and everything. And in this GitHub repo itself, I have provided a reference guide as well that can be followed uh, to implement whatever given in the GitHub repo. So in this YouTube video, we will be focusing on the architecture and the installation part only. And along with my GitHub repo link, I have provided the official project links as well for the Tekton. Okay, so what exact problem the Tekton solves for which we should prefer it over any other CI/CD tool? So very common issue is any other CI/CD tools usually run outside of the Kubernetes cluster, like standalone virtual machine or actual bare metal host, so which needs a separate management. So that's kind of a burden for sure. And what about the resource inefficiency? For example, if your uh, particular cluster or workloads are not expecting any changes, or let's say there is no pull request, there are no push events, so your CI/CD system will be sitting idle and the resource will be wasting. In case of Tekton, like those pods, those pipeline runs will be executed once any changes are there in the GitHub repo. So those things get automatically triggered, and no supply chain guarantees there. Like the supply chain related features are very limited in any other tool in comparison to the Tekton. And what about the portability lock-in? Like any other tools related to the CI/CD are heavily dependent on the vendor, so that's one of the other reason to prefer Tekton. So we have already discussed like what is Tekton, and this is the very basic architecture of the Tekton. So let's say you are having any GitHub repo and there is any pull request or any changes in the code. So Tekton triggers are there. Basically, Tekton triggers is comprised of three things like event listener, trigger binding, and trigger template. So as soon as there is any code changes, any pull request in your GitHub repo, the event listener will quickly catch it, and then it will pass on the particular data to the trigger binding. Like basically what happens, the webhook is there, trigger binding is aware, okay, we got a particular event, and trigger binding will extract the required details from that particular payload, like what is the GitHub repo, the commit SHA, and all those things. And then trigger binding will pass on those things to the trigger template. And trigger template is nothing, just the definition we can say with which a pipeline run gets created. So we will discuss about what is pipeline run, task, and everything after a few minutes. So once the trigger template creates a pipeline run, so the pipeline run will be starting lots of containers, and those containers are just a part of task run and all. So lots of things will be going on. All right. So the core components for the like Tekton are like task and the task run. So task is just a set of steps that runs sequentially to accomplish one job. We can say like compiling a code or running unit tests. So each step runs in its own container, but all steps share the same pod. So they can pass files between each other. And the task run is like what happens when you actually execute a task. It creates a pod, runs each step's container in order, and reports success or failure. And then comes the pipelines and pipeline runs. So pipeline basically we can say strings multiple tasks together in a defined order. with dependencies. Example, build must finish before test starts, and then test before deploy. So basically, pipeline is just the sequence of whatever tasks we have created. And then the pipeline run. So pipeline run is the actual execution of a pipeline. It triggers the individual task runs for each task in the right order and it tracks overall like status. So basically, if we go by order, so pipeline run executes, pipeline runs will be referring to certain pipelines which are created, and the pipeline runs will be having those tasks, and to execute those tasks, the task runs will be there. And another core component is workspace. So workspace is just like a shared storage that tasks and pipelines uses to pass files, data between steps or between different tasks. So just like we can say source code checked out in one of the tasks and then built in the next task. So workspaces, we can say a shared storage between a complete pipeline run. And the Tekton triggers that we already discussed. And then comes very important part, the Tekton chains. So Tekton chains focuses on supply chain security. Basically, it observes task runs, pipeline runs as they complete, and they automatically generate and signs metadata like SLSA about how an artifact, for example, container image was built, capturing what inputs, steps, and commands produced it. This can be stored and validated later to prove the artifact wasn't tampered with. So it's a very, very important feature of Tekton, we can say. And then comes the Tekton dashboard where we can monitor any pipeline or task run is there. So all those things we can check out in UI. And like why engineering team chooses Tekton over any other CI/CD tool is definitely everything in Kubernetes. Like it runs inside your Kubernetes cluster. You can manage your CI/CD tool just like any other workload with the help of resource quotas, network policies, and RBAC, and lots of things. And definitely infinite horizontal scalability. So Tekton pipelines just scale with your cluster. Let's say when hundreds of pull requests are there simultaneously, then Tekton will be creating the required amount of pipeline runs, and those workloads will be getting scheduled across the available nodes. So that's why it is very easy to maintain and schedule the pipeline runs and pods in your Kubernetes cluster for this CI/CD system. So these are some of the benefits that you can go through the blog post afterwards. And like who uses Tekton in production? So right now, like if you are having an OpenShift cluster, so OpenShift Pipelines operators, they are officially provided by Red Hat. So it is built on top of Tekton only. And Red Hat Konflux. So Konflux is also built on top of Tekton only. So it's Red Hat internal developer platform that builds, signs, scans, and releases thousands of container images per day. So yeah. Okay, so now let's get started with the installation. So in this particular GitHub repo of mine, under this installation directory, there are two YAML files, or I will say one YAML file and another one is the shell script just containing the commands. So if we open this command shell script, so in this post, I have covered the kind cluster to use, but you can use any other cluster to install the Tekton, maybe OpenShift cluster, or instead of kind cluster, you might be having a fully fledged Kubernetes cluster. So on macOS, we can install the kind cluster with the Homebrew package. So it's already installed in my Mac machine. So if I run brew install kind, then it will say the package is already installed. And on the Linux machine, you can download the kind binary and run it on the PowerShell. If you are using a Windows system, then you need to install the Choco package manager. And then we can create a kind cluster. If you are also following up with me uh, using the kind cluster, then we can follow these steps right away. So the kind is already there in my system. It just updated it maybe. Okay, so there is one important file that we will be using to create the kind cluster is this particular kind config.yaml. If I open this YAML file, we will see some of the things configured, like on which particular ports, like certain things will be accessible, like extra port mappings is there. And yeah, the ingress part as well. So what I will do first, I will clone this particular repo, git clone. Okay, and I will go inside this particular directory, and again going back to the commands, and we can just run this particular command kind cluster create config and the kind config YAML. So I will go to the first directory and I will just run this command. So it's just bringing up a single node Kubernetes cluster, and it will apply whatever the configuration is there in this YAML file. So once that is up, we will be installing the Tekton pipelines, the latest stable version with this particular command. So all these commands are taken from the official documentation only. So we will just wait for the cluster to come up. Okay, so the cluster is up now, and we can run this command. Okay, so the cluster is up, kubectl get nodes. Okay, it is in not ready state. So few things are still coming up. Let's check if all the pods are up or not. I think it should be ready now. Okay, the cluster is ready now, and we can install the pipelines, Tekton pipeline basically. So as you can see, it creates lots of objects in the cluster, like RBAC, the custom resources, and everything related to it. Okay, once this is done, we can verify the pods which are there now. So as you can see in this particular project, Tekton pipelines, certain pods are there, and the pipeline resolver and few other things. So we can run this command to wait for Tekton controller to become ready. Okay, so it's already ready now. Let me check the pods again. Yep, so the controller is ready. The webhook and uh, this particular pipeline remote resolver is still coming up. That is fine. Okay, and then we can install the Tekton dashboard as well to access the things over UI. Okay, so now let's check the pod status again. Okay, so the dashboard pod is coming up. All right, it will also become ready eventually. Okay, everything is up now. Okay, and the TKN binary should also be there, so you can access the core components of the Tekton like PR, pipeline run, and those things. Like those are accessible with the kubectl as well, but the TKey and CLI binary provide lots of functionality. So I'm on Mac, so I will run this particular command: brew install Tekton cd-cli. It's already installed. Over the Linux, you can install it by downloading the binary from this particular URL, official URL, and putting it in your USR local bin path. So once the binary is there, we can verify it, TK and version. Okay, so this is my client version. Okay, and now all the pods are up and ready. We can verify the CRDs related to the Tekton which are there after we install the Tekton. So these are the custom resources like pipelines, pipeline runs we were discussing earlier, task runs, task. So all these things are there. And some of the specifications or the syntax about the task runs can be understood with the help of kubectl explain functionality. So let's say if we want to understand what parameters and what configuration can be done in a task YAML file, so you can just run kubectl explain task.spec. So all these parameters are there basically. And similarly, you can check for pipeline runs and pipelines. So yeah, Tekton installation has been done, and we can try to access the dashboard for the Tekton pipelines with this command. So kubectl forward, we are just doing port forwarding, and there is a service present in this particular project with the name of Tekton dashboard, and we will we will access it on this particular port only. Okay, so now we can open this URL on our local host. We have port forwarded it on this port. So if I go to my web browser, so as you can see, this is our Tekton dashboard. Yep, so that was it for this particular video. And in the next video, we will be covering about task runs, and lots of things. So yeah, thanks everyone.